Alright, we're here at go2math.com doing something. About pause the video there. Let's go down to volume disk methods, what we're doing, and 2.1 looks like. Alright, so now if you worked 1.1 and 1.2, remember the radius was constant. Well, guess what? The radius is now changing. The radius is changing, right, with respect to x. And but we could still use geometry. No, could we? No, not really. We could actually drive up a general formula though using calculus. Yes, we could. Alright, so what does this thing look like? It looks like a flying saucer, maybe a disc with a pointed end. I don't know. I'll try to draw it out on a piece of paper. It's a cone, really. Solid cone, maybe a solid cone. Let's write this. Let's write this down. Everybody write this down. Everybody do that now. F of x is equal to 2x going from 0 to 8. Right. So if you can imagine, this is a cross section right here, and we're going to be revolving this about the x-axis and seeing what kind of thing we get. But you know, really technically, I don't know. What's really going on here is just our radius is varying. The radius, you know, I guess deeply we need to understand what's really going on. The radius is changing, so you can utilize use this concept or expand on it, spin it into other areas. All right. Did we write that down? Let's go over to the whiteboard. Let's just do it. All right. Let me see if I can't try to sketch something out here. So what we've really got here is a cone. It's a cone. That should be a dotted line right there. And we're finding the volume of this cone. It's not a very good cone. Anyway, we're finding the volume of a cone. Yeah. Okay. Of course, this uh, hmm, it's kind of flipped around, but that's what's going on. Okay. So remember our formula here. Pi, the radius is varying. It's squared times dx. Right, this is the volume. And remember, to find the volume of a cylinder, it's pi r squared times h. So you can see h is kind of like our dx because that's our height. Are we going that way? We're going this way, aren't we? And but the radius is changing. Okay, the radius is changing. I guess I need to write some stuff down over here. F of x is equal to 2x, and we're on the interval between 0 and 8. 0 and 8. Alright, I guess we'll just sketch this out again. So something like that. And there's 8. Alright, and technically they always say we're revolving this piece here around the x-axis. Okay. Alright, so this is our radius, and the radius is changing. Okay. So all we got to do is use this. Now we call this the, man, I keep wanting to write that number down, or washer disk method. The disk method's what they call this. So let's go ahead. So we got pi. We got this right here is our radius function, squared dx. And of course we can rewrite this as 4x squared dx. Okay. So we end up with 4x cubed over 3. I forgot to write down our limits here, 0 to 8. My God. Losing it. 0 to 8. So we plug in 8. So we have pi times 4/3 times 8 cubed minus, then plug 0 in, and you get 0. All right. So let's figure out what those numbers are real quick. 4 times 8 cubed, I'll let you do that in your head. And I'll just, are we supposed to round or anything in this problem? I can't remember. For rounding, 2, 0, 4, 8 over 3 pi, that's what I get. And there are formulas for finding solids of cones out there. We could actually derive one up. Alright, well that's what I get anyway. So I'm sure it's right. I've checked it like 10 times using other algebraic systems. Alright, so come on over to go2math.com, check that out, practice that, and I'll see you later.